Good evening to everyone. This is Monica. In today's Hindu news analysis, we are going to discuss about a very exciting topic called Thermo. So before going into the context, I just want to give an idea of what it is. So here we have to know about the tone of the why? Because one of the the pattern tone of the only then we can able to get a pattern. So here there is the application part. So this is the definition. This is the another relevant concept called meridian overturning circulation. And find this in the calculation. The answer is questioning the factors involved in the thermo. So please basically try to say that okay. So you are saying that these factors are responsible for the thermohaline. So the which so such kind of questions when you write in such kind of questions. So this is basically the idea of the overall article. So only when you get to know about the overall idea of the article, then you will get a very good pattern. Right? So just get the pattern. Then we'll get into the concepts. So now it is clear. So now for the exam point of view, we have to know about these many things. So ocean circulation in general, then ocean currents in specific, and types of ocean currents, and thermohaline circulation and its significance. So these are the 5 areas which we are going to discuss today. So we'll start with the ocean circulation. So ocean circulation is very clear. In a generic term, it is a large scale movement of ocean water. So it is a very generic definition because the word itself, it is very generic. We are not talking about anything specific. So when it comes to the ocean circulation, we are having 3 different types. So one is tides, another one is waves, another one is ocean currents, right? So even though we are having 3 different types, today we will be discussing only ocean currents because it is very much relevant to the thermohaline circulation, and even thermohaline circulation is also an ocean current. So we'll start with the definition of ocean currents. So the definition is very much clear. So it is a constant movement of a mass of ocean water in a definite direction over a period of time at the surface as well as the deep ocean waters. So we have to be very careful in picking the keywords within the definition. So I'll write it once again. So first one is constant movements, right? So movement of the water should be the basic criteria of the ocean current. Then mass, which means it is not a very small amount of water. The huge volume of water is moving. So that is the second idea. And the third idea is it is moving in a definite direction. So that is the third idea. And the fourth one is the idea of its location. It can be either at the surface level or at the deep ocean level. So these are the basic keywords which we have to know in terms of ocean currents. So in simple terms, I can tell you that the ocean current is something similar to the river which is on the continents. For example, look at this one. The water is moving like this. So it is something like a river within the ocean. So the movement is the movement of water in a large scale manner, and it is happening in a definite direction is what we call it as ocean currents. So next we are having the types. So here I'm not going to talk about the entire types of ocean currents we are having. Based on the temperature we are having different types, based on the location we are having the different types, so based on the vertical area we are having the different types. But here we are going to talk about the only two things. One is surface ocean currents, another one is deep ocean currents. So when we look at the reason for its formation, the surface ocean currents are formed because of the winds. So for example, this is Earth, this is equator, this is trade winds, right? And because of this trade winds, the water is getting or pushed towards this direction, and this is what we call it as equatorial current, right? So because of the movement of the wind, or when the air is moving over a particular part of the ocean, it also tend to pull the ocean water along its direction, and this is what we call it as surface currents. So it's basically formed because of the influence of winds. So this is the first part, and second one is deep ocean currents. So deep ocean current is happen because of density differences, right? So here I'll explain you with the diagram. So this is the cross section of the ocean. So we can assume that this is equator, so near a tropical region, and this is like we are having ice, no? So this is polar region. So here temperature is high. So temperature of ocean water is also high. Because of this reason, expansion of water will be there. Thus, the ocean water becomes less dense and it tends to float. Right? So, near the equator, the ocean water tend to float, right? Okay. So here in the polar region, temperature is low. So water molecules tend to pack itself in a very limited region. So it also contributes to the density, which is it increases. The reduction in the temperature increases the density, that is one point. And apart from that, during the ice formation, the precipitation of salt will be there. Thus increases the salinity of the water. So here, temperature, and because of the salinity, the density of the water is high, right? So we know that the denser water tend to go down because of the gravity, right? So here in this region, the water tend to move to the surface level due to the buoyancy, right? So here there will be a space. So in order to occupy this space, this water tend to flow like this, and then in order to fill this gap, the water from the polar region moves like this. Thus it sets in a circular motion or circulation. So here I want to make you clear of two things. So one is temperature, another one is salinity. So these are the two parameters which involves in the circulation of the ocean water. So these are the two parameters which induces density difference within the ocean water, that induces the movement of water, right? So this is what we call it as thermohaline circulation. So that's why then we are having the name. Thermo means temperature, haline means salinity, right? So this is the idea behind the thermohaline circulation. So now when it comes to the characteristics, it is not limited to any ocean. Instead, it forms a conveyor belt mechanism like this. Okay, so the water is moving like this, and then it is coming to this direction, and it is flowing this way, and it is entering into the Indian Ocean, and another branch is moving into the Pacific Ocean, and then it is returning back, and it is moving into the Indian Ocean, where it joins with the Indian Ocean branch, and after that it is moving into the Atlantic Ocean. Thus it completes a cycle, right? So as a whole, it looks like a conveyor belt. So that's why thermohaline circulation is also called as global conveyor belt mechanism, right? So it is not limited, it's forming a cycle and it moves across the ocean. So it is also, so that's why it is called as global conveyor belts. So next we are having a relevant topic which is called meridional overturning circulation, right? So we all know that like prime meridian, so which is nothing but an imaginary line passing through the Greenwich, which we are using it for the to calculate the standard times of other regions. So meridian is nothing but an imaginary line running between the poles. So here also the idea of meridional connotates the same idea, that the ocean current is moving along the meridians. So like this, okay, it is moving like this, and then it is moving like this. So specifically in the North Atlantic Ocean, so we can able to see the overturning mechanism. Look at here. So the water is moving like this, and it is returning back to the tropics like this. So it is moving like this, and then it is returning back like this. So the water is moving in a meridional direction, and it is taking a U-turn in the northern part of North Atlantic Ocean, and this is very unique to the Atlantic Ocean. Even though we can see something similar in Indian Ocean as well as the Pacific Ocean, but it is not up to the level of overturning which is happening in the Atlantic Ocean. So that's why it is very unique, and it is influencing the climatic conditions of the northern, the coastal regions as well as the Arctic regions of Atlantic Ocean. Clear? So because of this unique presence in the Atlantic Ocean, it is also called as Atlantic Meridional Overturning Circulation, or AMOC. Clear? Right. So moving to the last part of the discussion, we are having the significance or role. So here basically we are going to talk about the environmental role which is there for the thermohaline circulation. So basically it acts in two different fashions. One is redistribution of energy, another one is redistribution of matter. So here the energy is nothing but the heat energy, right? So we know that the energy from the tropical region, that is heat energy from the tropical region, is transported to the polar region, and it can also the cold water from the polar region transported to the tropical region. This is happening here as well. So thus it balances the energy level of overall Earth, right? It maintains the energy level or heat energy of the Earth's surface. Thus it helps in redistributing energy. That is one point. And after that, it is also helpful in the redistribution of matter, either salinity or either nutrients or gases such as oxygen or carbon dioxide, right? So in doing the redistribution of matter, so thermohaline circulation is also very much important for the carbon cycle. Thus it influences the overall climatic condition of the earth. So that's why, like, this is what in the initial area, the article, the author was discussing about the idea. Okay, what would be the condition if the pace of thermohaline circulation increases or decreases? So why is skeptical? Because nowadays the pace of thermohaline circulation is a bit changing. So that's why he's wanted to give as a warning signal, or we want to present his idea in such a way to show the significance, how it is useful, what it is, and how it is significant, and how it has to be. So that's all about the idea of thermohaline circulation. So I'll meet you with another interesting article in the next session. Till then, bye.